Good morning, everyone. This is our last video of the year. I cannot believe it. But today we are going to start 17.2. And the first thing that we're going to talk about is properties of a mechanical wave. So, periodic motion is any motion that repeats itself at a regular time interval. So the example out of the book that they talked about was surfers counting the waves. And how they do that is if they count the time between two successive crests, so that's the top of the waves. So successful crests, the next crest usually will come after the same time interval. So they'll count the crest, and then that would be it would repeat itself at a regular time interval after two successful crests. Then we have a period, which is the time required for one cycle or a complete motion to return to its starting point. So this would be the time between the two successive waves. So remember, let's go back to what a period is. A period is time required for one cycle or a complete motion to return to its starting point. So for an ocean wave, the period is the time between the two successful crests. Remember, periodic motion is it's repeating itself, right? So that's like you can count the two successful waves, then the third wave should come at the same time interval. Then a period is the time between the two crests. So kind of in the middle, how they crest, and then they go down to the trough, and then up to the crest. It would be that time in between the crest. Frequency. So frequency is the number of complete cycles in a given time, the number of wave cycles that pass a point in a given time. So we look at this in hertz. That is how we're going to measure frequency. So if we take a picture at this, if we look at the picture below at low frequency, medium frequency, high frequency, we can see that low frequency doesn't have as many crests in that given period of time. You can see as your frequency increases, you are going to have more crest in that period of time. So a wave's frequency equals the frequency of the vibrating source producing the wave. So if we have a low frequency or a low vibration, we're going to have a low frequency. We have a medium vibration, then it's going to be a medium frequency, then high vibration, high frequency. And remember that we are going to measure this in in hertz. So a wavelength is the distance between a point on one wave and the same point on the next cycle of a wave. So we can look down at this picture, the red vertical line. I'm sorry, guys. Vertical line to the other vertical line, that is a wavelength. So you can do for longitudinal waves, it's going to be from compression to compression or refraction to refraction. For transverse waves, it is going to be crest to crest or trough to trough, whichever one you want to do. Longitudinal, compression to compression or refraction to refraction. Transverse waves is going to be crest to crest or trough to trough. That is going to be the wavelength. So frequency and wavelength are inversely proportional. So if you have a high frequency, you're going to have a shorter wavelength. And you can see that in that picture. That has a high frequency because there's lots of crest in that little area, and then their wavelengths are going to be very short because they are going to be going up and down very quickly. So you're not going to have a long period in between crest to crest. Then you have a lower frequency, you're going to have a longer wavelength. So it's going to be going up and down, but not as quick. So you're going to have some time between those crests. So remember, frequency and wavelength are inversely proportional. So they're going to do opposite of each other. All right, let's get into wave speed. It can be determined by calculating the wavelength times the frequency, or it can be the wavelength divided by the period. So there's our little triangle. Wave speed is going to be V. Wavelength is going to kind of be the upside down Y, and then frequency is going to be hertz. For this, wavelength is going to be in meters, but you can also have it in centimeters or kilometers. Any of those will work. So if I give you a problem in centimeters, just keep it in centimeters. If I give you a problem in meters, keep it in meters. If I give it to you in kilometers, keep it in kilometers. So let's go to page 506, and this is just the problem that they're doing step by step so we can do it together. So look at your book and also look at this video. So it says one of the end of the rope is vibrated to produce a wave with a wavelength of 0.25 meters. The frequency of the wave is 3.0 hertz. What is the speed of the wave? Well, we know that our formula is going to be speed equals wavelength times frequency. It says right there that our wavelength is 0.25 and that our frequency is going to be 3.0. So all you have to do is multiply those and you will get 0.75. And for frequency, that would be meters per second is what our speed is going to be. Meters per second. So look at that problem and look at what I just explained to you, and hopefully you can understand that. For homework today, you are going to be doing the math practice 1 through 4. So then on our Zoom session on Wednesday, if you guys have any questions about those math problems, then you can let me know. They're pretty simple as long as you know how to plug it in to the formula. Amplitude. So amplitude is the maximum displacement of the medium from its rest point. So more energy you have, the greater the amplitude it's going to be. So if you are just going up and down, kind of flowing through it, you're not going to have a huge amplitude. If you have more energy behind it, you're going to have shorter wavelengths, the frequency is going to be higher, and you're going to have a higher amplitude because you're going to have more vibration behind whatever is causing the wave to be vibrated. So you have to think it's from the middle up to the top of the wave. So it's the displacement of the medium from its rest point. So if water was completely flat, you would start there, and then as it waves up, you would go to the top of that crest and measure it. So that is what amplitude is. All right. So I want to show you some stuff with the Slinky because I love the Slinky and I think it's fun to work with. So just let me pause and let me go get my Slinky. All right, guys. Walter decided he wanted to join for this part of the video. But let me get back to this slide. Okay, so with the Slinky, low frequency, medium frequency, high frequency. You can hardly see it. Low frequency, medium frequency, high frequency. All right, let's do it again. Low frequency, medium frequency, high frequency. So that's just an example of the difference between low, medium, and high. And then what I wanted to show you is if you have a high frequency, you're going to have a shorter wavelength. So high frequency, you can hardly see, oh, you didn't like that one. You can see how the wavelengths are very short. That's crest to crest. Then you have lower frequency, you're going to have longer wavelengths. So you can actually see the crest to crest. So once again, high frequency, Walker, you gotta get out so they can see. Come on. Sorry for the inconvenience. Low frequency, longer wavelength. High frequency, shorter wavelength. Same thing this way. Remember, compression to compression, refraction to refraction. Low frequency, high frequency. All right. Let me also do the amplitude for you guys. So, you can have, here would be the resting position. Then your amplitude is going to be how high you're cresting. So those are going to have larger amplitude. This one's going to have shorter amplitude. There you go. So I hope this video helped you guys out a little bit. Me and Walter are definitely going to miss you guys. We're going to miss making these videos, even though he really hates me right now because of Slinky. But we're going to miss you guys, and I can't wait to see you guys next year. But the Zoom session for Wednesday is mandatory because I want to see your guys' faces and come with questions. But all right, guys, we hope that you have a wonderful Tuesday. Do your assignment. Your assignment will be on Teams, and then you also are supposed to do the math problems on the math practice on 506. You're doing 1 through 4, and then I will give you a answer sheet to both of those on Wednesday. And then please come with any questions that you guys might have on Wednesday. Do not forget that the Zoom session is mandatory because I want to see all of your faces before the end of the year. So have a great day, guys. See ya.